Hello, my name is Enno. This is my first video in my rule writing series, which aims to be different from my quick tip series in that I want to showcase the entire process for writing a rule, including the different thoughts and considerations that I have, as well as my debugging process. So let's get into it. This rule as it is here, and this test code, these tests currently do not pass. And so the premise of the rule is they want to flag every query dot with for update function call where the return value goes unused. And so that includes being assigned to a variable, being returned, being used in a for loop, a list comprehension, and having subsequent method calls with a .all at the very end. So there's two things that really stick out to me here. First, they're using pattern not instead of pattern not inside. And I have a previous video explaining the difference between the two. I will link to it in the description. But basically, if you use pattern not inside, we'll see that a lot of their findings disappear. And so I ran the rule again. We can see that it got rid of a ton of findings, and there's only this one left. And so what's the issue here? Here they have this query .with for update .whatever .all. Okay, so here's another issue. They're hard coding some amount of method calls when instead Semgrep has a dot operator. If you use dot, and then a, I'm gonna just go to this line here. So if we do this, what this does, so in Semgrep, is basically saying capture 0 or more of something. For example, this pattern with the inside the function arguments captures 0 arguments and 1 argument, and also if we do multiple arguments like that, then it captures any amount of arguments, so 0 or more. That also applies to function calls if they're in a chain. And so this will filter out cases where 1 or more functions are called on it. And it's 1 instead of 0 this time because there's an explicit method call at the end. So this is basically query.with for update however many method calls could be 0 plus a last one. So we can do that for all of these. And let's see what happens. Okay, cool. So all the tests pass. And so while this does fix the user's rule, I'd feel a little bad if I just left it off there. I think the video would be a little bit boring. So what I could do instead is go taint mode. And by that, I mean teach you about the internal logic for Semgrep's taint tracking capability, which is called taint mode, and how we can kind of abuse how it works internally to rewrite this rule in a way that taint mode isn't really meant to be used, but it still works out pretty well. And I think you'll also learn a lot along the way. And so a brief overview of taint mode. How taint tracking works is it tracks data as it flows through a program from what's called a source, which we define as get user input in this case, here, to a sink, which we define as either HTML output or eval. Here we just use HTML output. So if we run this rule, you can see Semgrep is able to track data as it flows from this function call to this data variable into this other function call. So from source to sink. And it also has a thing called sanitizers, where basically it removes taint from a tainted thing. So here, data is tainted, and then it goes into sanitize input, and then it's no longer tainted, which is why there's no match here. But so how taint mode actually works is, so when Semgrep matches something, it uses the same pattern matching logic for all of these, for like a pattern not, and for matching sources and sinks and sanitizers in taint mode, it uses this thing called a range. So a range is quite literally the byte range in the file that your source or sink or pattern or whatever occupies. So if we have like ABC and then get user input, it's great Python code. When it finds this source, Semgrep goes, okay, there's a source at 1, 2, 3, new line 4 from byte range 5 in the file to whatever the byte number that the right parentheses occupies. And so it just says, okay, one match is from here to here. And when it finds a sink, it does the same, where it goes eval, and then it goes, there is a match from this byte number where the E is to this byte number where the right parentheses is. And so how taint mode works is it just checks that a tainted thing goes into a sink, which is why if we put this entirely inside here, this works because the range of the source is within the range of the sink. And so going back to this rule, so we can turn it into a taint mode rule. So what we're going to do is have the source and the sink be the same. And so given my previous explanation, you might guess that doing this would flag every call of query.withForUpdate because the source and the sink are the same range. The source range is technically within the sink range, therefore it flags every function call that's query.withForUpdate. And so for sanitizers, we want to basically abuse Semgrep using ranges. And what we can do is keep these in a comment for now so you can reference them. Define pattern. That's a variable assignment var . And so you'll see that this one disappears. Ta-da. Because the sanitizer matches from the beginning of query to the end of the line, which this ... goes until. And so we could do the same with return. And also with a for loop for var in ... And then also a list comprehension, or just in a list, I guess. And also in a call chain that ends with .all. Copy paste that, all. Okay, cool, we're passing all the tests anyways. We could add more things where a variable is used in Python. So what about in a tuple? This will be interesting. If I run this now, this match disappears completely. I don't know for sure why, but I have a theory. I think what's happening is because in other languages, the parentheses is just like something. I think this is like sanitizing everything, which includes a function call like this. So I think that's a little bit too much. What we can do to make sure that this is actually sanitizing tuples is force at least one thing to be in it. And so this reappears. And I guess we could do the same for a list. Why not? So if we want to test that out, we could just put this in a tuple. And now that disappears. But if we remove it, then it reappears. Woohoo. Cool. Okay, so one thing we could also do is, what if it's in a dictionary thing? What's the syntax? Like something else? Maybe? Okay, that parsed. So that's a valid pattern for Python. So what if we do like, cool, so that works too. That captures another case where this thing is used. Yeah, that's all I can think of right now, but you get the point. Basically, by using Taint Mode, like how it kind of operates on ranges, we can write rules in interesting ways and hopefully learn a lot along the way too in some random YouTube video. This has actually come in handy a decent amount during my job. There has been some rules that I just wasn't able to write very well with Semgrep's default mode, which is called search mode, but I was able to use Taint Mode's range logic to make it work better. In this case, it's probably not a much better rule than the original search mode rule, but it did allow me to demonstrate the concept pretty well, I think. So, my name is Enno. This has been my first rule writing video, and so let me know what you think of it in the comments. If you enjoyed, be sure to follow me on Twitter @encoded and subscribe for more videos in the future. Thanks for watching.